It's no secret that JavaScript isn't the fastest language, like by quite a bit. I'm not going to sit here and pretend that JavaScript's fast enough because in so many cases it isn't. If you're processing lots of requests and not using serverless, or you're encoding video or trying to build a game, it's really hard to justify doing a lot of these types of things in JS just due to the performance issues. What if I told you there was a solution being worked on, and it's being worked on by some of the most talented JavaScript engineers in the world? What if I told you they have the right incentives to actually make it happen? So much so that it's not just Meta working on it anymore, but also Amazon. What if JavaScript actually ran at the same speed as C because it was actually C code being run instead? As a quick spoiler, I want to show you guys how crazy these things have gotten. Here is some JavaScript code that is very rudimentary JavaScript code running at 120 hertz on his MacBook, but more importantly, running at 60 hertz on an old Motorola G5 phone. This is a full-on window manager where you can change tasks with them all running at really high frame rates, written in JavaScript, live at 60 FPS. That's nuts. Is it actually possible to transpile our JavaScript into C and to write a compiler that's smart enough to make static code out of our JavaScript? This is the question that the static Hermes team has been asking themselves for a bit now, and goddamn, are the results impressive. Let's take a look at what static Hermes is and the effort that the team's been putting into making JavaScript a little bit more static. So there's an incredible talk that the lead dev on static Hermes did. We're going to skim through it a bit here and take a look at some of the really, really cool outputs. So without further ado, let's see how this actually works.
All right, so my name is Cvetan Mikov, and I helped create the Hermes JavaScript engine at Meta. So I can tell that there are at least 2-3 users of Hermes in the audience. Can you make some noise so I can hear you? I need the support.
For context, for anybody who doesn't know what Hermes is, it's a custom JavaScript runtime and kind of compiler for JS. The goal is to skip a lot of the runtime steps necessary to initialize JavaScript by just-in-time compiling a lot of the pieces. And the result is when you want to start a JavaScript VM, it starts way, way faster because it knows what parts are going to be where as it starts, rather than letting V8 figure that out later. This was created so that React Native apps can open much more immediately rather than having to wait for JS to load before the rest of the code is running. Static Hermes is a huge step forward, going even further in, where instead of it pre-compiling the JavaScript part so that it knows where the memory is being initialized, it's actually just running C code directly.
For two people, you guys are really loud, I have to say. Anyway, last time I was here, I was really pleasantly surprised by the reaction to my talk. After my talk, a couple of people approached me to tell me that the talk was very technical, but okay. So let's hope we can live up to this standard once more. I want to start by telling you a little story. This is the sad fable of Joe Native and his slow code. Joe was sad because he was having performance problems in his React Native app. The startup was very fast because of Hermes, but there was occasional UI stutter when scrolling very long lists, when using complex animations, or when computing crypto hashes, or mining a bit of Bitcoin in pure JavaScript.
I will say that the list example has gotten much better with FastList. There's a new library that Shopify made that's basically the drop-in replacement for the list component in React Native, and it's absurdly fast. It's FlashList. Thank you, chat, for the correction. FlashList is nuts. I played with it a tiny bit, and the result is really, really, really fast. It's a faster React Native list. You don't have to worry about the blank cells appearing as you scroll too fast anymore. It just works. They did a ton of insane optimization, and the result's really, really fast. If you've used the Shop app, like shop.app by Shopify, it uses this, and the result is phenomenal. I thought that was a native app. I actually hit up some of my friends to confirm if it was or wasn't, and was surprised to learn it was React Native, because as much as React Native is native and can feel fast, getting to that level of performance is nuts. And yeah, there's a reason that Shopify works as hard as they do on these things, because they want to make these things great. Anyways, everything else he said, like near the end, the Bitcoin mining, complex animations from JavaScript, all those types of things. Usually we go to native and just tell the native code what we want from JS land. But the idea of our JavaScript actually doing those things, that's insanity.
Problems that we all have had, obviously. Joe, who was a very passionate programmer, very passionate, tried and tried during a 50-hour coding marathon. He swore, he drank gallons of coffee, he profiled, he optimized his code, he rewrote it over and over, but ultimately, he was faced with the fundamental limit of interpreter performance. He could not make his JavaScript any faster. It was beyond his control. Deadly tired, with a crushed spirit, but boiling anger.
Someone in chat just pointed out they're wearing the same shirt. Good old AI generation.
Poor Joe was considering making his final move of total desperation, trying to rewrite some of his code in C++. But then he wondered, what if I could leverage type information to generate efficient native code ahead of time? I would still be writing JavaScript, but I would be in control of performance, not the Hermes interpreter, which is actually great. And I could optimize as much as I need. Could I do that? Joe wondered. And the answer to that is yes. Yes, you can, Joe.
Love the Comic Sans here. And this slide is very important. This is what makes static Hermes so different, is it's using type information to generate native code. We're going to have to take a lot of jumps in order to get there, but that's the core piece here, is we're using type information to generate static code. Because dynamic code, where something could be a number or a string, making that memory efficient and functional in C or C++ that's a different world. But if you know it's always going to be a string, you could make optimizations that you wouldn't otherwise be able to. Or if you know it's always going to be static, you can make optimizations you wouldn't otherwise be able to. But we're going to get into all this.
You can do all of those things and more. As part of our cross-platform vision, we really want to unleash JS developers like Joe and give them access to the unchecked power that native code has to offer. Optionally, if Joe really wanted, he can even carefully perform unsafe operations, potentially not only creating harmless web JavaScript crashes, but also devastating native crashes, just as C++ developers regularly do.
Gotta love enabling JavaScript devs to crash things just as hard as everyone else does.
And look at him, he's so happy. He doesn't know what he's getting into. But seriously, he will mostly get tons of performance. And on that highly optimistic note, I am excited to introduce the next version of Hermes, which we have been working on for some time now, codenamed Static Hermes. Some of you may have already heard some speculation about it on Twitter. It was not meant to be a secret.
This is another important piece. Something I feel like we don't see much in the web world that is very common in the React Native world in particular is this level of like open secrets. The React Native team isn't really trying to hide what they're working on. They're not loudly talking about every piece because a lot of it ends up failing. But they have all these efforts going on in the background, and when they work great. And when they don't, that's fine too. But the goal is to try and figure out just how far they can push the React Native platform. And they want collaboration throughout. And they've been very open to working with other companies, independent developers, firms like Infinite Red, and doing whatever they can to make a great React Native experience that works for all the different things people use React Native for. A lot of us have known about Static Hermes for a bit now. They haven't been trying to hide it, but they haven't been very loud about it yet because they didn't know if it was going to work. The fact that they're now talking about it at conferences, they're talking about it on Twitter, they're doing all these other things, that's because they're more confident they can actually get there now. But in this slide, there's actually a lot of important pieces. I'm going to let him finish, then I'm going to dig into the parts.
It was on GitHub since day one. But we didn't really want to talk about it because there was nothing to show. Well, now finally there is something to show, and we are eager to share it with you. The main innovation of Static Hermes, as you have guessed already, is optional ahead of time compilation of JavaScript to native code. It brings us close to our goal of combining the predictability and high performance of C with JavaScript usability. And no, despite what the last slide said, natively compiled JS is completely safe by default, exactly as interpreted JS. So there will not be native crashes for Joe. To be clear, native compilation is not for your entire app, even though that is possible. You need to decide which parts of your code need to be optimized to the max. And
this is an important piece. I find that whenever there's a more optimal solution, we rush to shove everything into it. Like we're trying to run everything in bun, we're trying to run everything on edge. But with most of these solutions, the place they're strongest tends to be specific pieces of our chain. I actually think Golang in the Go community of all places is doing this well. I forgot the name of the change they're making, but they're allowing you to do specific memory management and mapping and opting out of garbage collection in specific sandboxes effectively inside of your Go applications. Where this is powerful is when you have specific dependencies or areas. People are, to me, it's called arenas is this new change. So in arenas, you're able to make much more performant code for the things that need that level of performance. And then you can call that code from garbage collection land. It's going to be very similar in JavaScript, especially in the React Native world, where you don't need C levels of performance when you're telling your app where to put which parts of the screen. When you say, I need a top nav, I need the bottom tab bar, it has these 4 icons. That code doesn't need to be optimized at that level. But the code that manages what changes when you scroll, the code that manages your animations, those types of things benefit a lot more from being C levels of performance. And calling this out this early, that although you could theoretically run your whole app through this, you probably only want certain parts. That's a really good call out, and very nice to hear this so early, where so many other attempts to rewrite everything are just that. They're trying to rewrite everything.
Only they get compiled to native ahead of time. The rest continues to use Hermes bytecode. And if you want to learn Hermes bytecode, I recommend a great talk by Radek, React Native EU 2023. You will find it on YouTube in a couple of weeks.
Emphasis on what he just said, as silly as it is, like the talks about this stuff are so cool. And I try my best to keep an eye on all these things in the React Native world, even if I'm not shipping as much React Native right now, because a lot of these tooling wins and performance wins come back to affect the rest of JavaScript. And yeah, it's really fun to keep an eye on. Check out these talks. Check out the other talks about Hermes if you're curious how this bytecode part actually works right now in production, because a lot of React Native apps, I'd argue even most of them now, are using the Hermes runtime already. They're not using the new static Hermes with like native code level stuff, but they are using the bytecode output so they can load their apps faster.
Now, the really big change here is that in order to fully exploit native performance, static Hermes relies on sound types. Now, even if you don't know what sound types are, remember these words, and we'll really delve into that a little bit deeper in a few slides. At this point, I want to make a big disclaimer. We are seeing encouraging results from static Hermes, but it is still very much a work in progress. Right now, it is not suitable for anyone besides the most extreme hackers and enthusiasts, like Radek. It is still not easy to use. Many things are broken. If you tried it, which you can, because it is on GitHub, you might get disappointed. But rest assured, we are working on it, and it is getting better all the time. Some of the Hermes team is here with me in React Native EU, and they are submitting diffs as we speak. So it is improving at this very second.
Diffs mentioned, graphite people going crazy. Yeah, they're all in on their diff stuff instead of traditional Git workflows, but it is really nice when you're moving fast. I love this call out that they're not pretending this is the magic solution that solves everything right now, calling out that they have positive indications, but it's not ready yet. It's a work in progress. They're showing it because they want community for feedback. And also that TypeScript support isn't something they built as the core team, but Amazon wanted it because they don't want to use fucking Flow. So they came in and helped early. Like these are really cool call outs. I feel like they're being very responsible with how they're going about this project.
With all that said, we really wanted to share it early with the React Native community and to get your feedback. We also want to thank our partner in this, Amazon, for adding TypeScript support to static Hermes, because internally we added Flow support. Amazon uses React Native in many of its apps, and it has been supporting us in growing React Native over the past few years. Okay, so this is a brief overview of the topics that we'll cover in this presentation. I could talk for hours about static Hermes, but I will try to fit everything in the remaining 20 minutes or so.
I love all of this. I highly recommend watching the whole talk, or if you want, Prime's reaction to the whole talk. But there's so much more to dive into here. I'm going to skip to the important pieces. Okay, I'm going to skip over a lot of important pieces. I just want to get to both the pain points of type unsoundness and how you can't rely on TypeScript definitions the way you would expect, because both TypeScript and Flow are not sound, where like this is supposed to be numbers, but we don't actually guarantee that at runtime. The compiler cannot rely on type annotations for better code, because you could do crazy stuff like this. If you know anything about native code, this should be stressing you out. The fact that you can call out things out of bounds here and try to add them in another external function, like have a nice seg fault, guys. So they're working hard on this part. Let me see what it actually says about this.
As I'm sure you know, there are many similar ways to break the type checkers. And this is not a bug in TypeScript or Flow. It is just that given JavaScript semantics, this problem cannot be solved statically at compile time. It is a very difficult problem. Here is how static Hermes addresses this problem in this specific example. On the left, we have regular Hermes executing this code. And as we can see, it's calling it with undefined plus undefined. On the right, we have static Hermes. Now, rather than call a function with undefined, it throws a range exception when we try to access elements that are not in range. So to recap, static Hermes modifies some JavaScript semantics in order to enable efficient sound typing at runtime. In other words, at runtime, the types of values are guaranteed to match the type annotations, which in turn allows us to compile that source very efficiently.
This is cool. They're doing some magic here for partial soundness in the parts that need that level of performance. Similar again to arenas in Go, where traditionally you don't worry about memory, but if you need to for performance reasons, you do in this subsection of your app, and then you can call that code from other places. That's the direction they're going in here, which I think makes a lot of sense. It lets you, on a granular level, rewrite and change the things that need these performance wins without affecting your ability to use that across other things in your app. Yeah, they talk a bit about, is this breaking JavaScript? But what I want to show is the performance differences. Also, great little meme here.
What compilation to native means for performance and what it looks like. The example we have chosen is nbody.js. Some of you may be familiar with it. It is a part of a well-known computer language benchmarks game. It is a math-heavy benchmark with many property accesses. When we started compiling it to native initially, it was the same performance as Hermes, and that is 550 milliseconds. But now, as you can see, it is 10 times faster when compiled natively. So
do you understand how insane this is? A different compiler resulting in code that is 10 times faster. This is nuts. This isn't faster compilation times. This isn't faster build times. This isn't faster like IDE performance. This is raw speed in the application you built.
That is not pretty shabby. Plus, we're certain that there is more headroom. We can probably get to 20 times faster than Hermes. 20 times. Okay, so we have this very nice performance improvement, but what does the compiled code look like? Let's examine this loop from nbody.js. How did it become so fast? Well, this is how. Before static Hermes, there were dozens of instructions executed for every line of this loop by the interpreter. With static Hermes, it is much better. And by the way, I'm really happy to bring some low-level assembler to this JavaScript conference. In the next slide, let's put the native in React Native.
I'm a little scared, but this is what we're here for. Let's see some native code.
Here we are. If you don't know ARM64 assembler, don't worry. I think you will still get the idea. The first thing to see is how few assembler instructions we have for the first 2 lines of the loop. We have 6 instructions. And most importantly, most of these instructions are very cheap. The entire calculation, the 2 multiplications and the 2 adds, are all performed in parallel by a single instruction, which is marked with red there, which is really impressive. And trust me, this is very fast. And it is quite exciting for compiler developers.
I haven't touched assembly since the ARM revolution, and you'll never convince me to care what FMLA.2D stands for. I would love to pull low-level learning on to explain some of this for me, and I could smile and nod as though I understand. But yeah, this is cool for the people it's cool for, and it's fast for the people who it's not cool for. So I'm excited.
This is the rest of the loop. Again, very few instructions. Again, you don't need to understand the details of this, but you can see how small the output is. And rest assured, this is indeed very fast. It is achieving performance close to C, much faster than Hermes, and we're not even done with it. It will become even faster. Sadly, I don't have time to explain how, but perhaps next year, when we hopefully would have shipped this. Now, a few more benchmarks. We can see the results of other benchmarks that we have created. They are in the static Hermes repository. They are not as impressive, but it's still not bad. One of them is like 5 times faster. And we're, again...
Yeah, the benchmarks are nuts. The rest of this talk is phenomenal. The reason this is cool is when you have native platform access, because you're writing code that becomes native, you now have no cost in native integrations. When you want to call something from the native platform, it's just there because you're there. There is no longer this virtualization layer in between getting in the way. The things you can do with that and the things they talk about with it here are really cool. Again, highly, highly recommend this talk. But I'm not here because of this talk. You guys should go watch it. I'm here because of the tweet that followed up, which I hinted at the beginning of this video. They wanted to show the performance and insane power of static Hermes native FFI. I should know what FFI stands for. I always forget this one. It's a foreign function interface, yes. It's a way to access foreign functions in the native level. But as they mentioned here, they don't yet support all language features needed to compile React Native, so they improvised. They imported the bindings from Dear IMGUI, which is a C++ imperative game UI library that renders meshes, as well as SoCal, which is a 3D backend, and they wrote a demo. So this is JavaScript code calling a C++ game library and a 3D backend from C. Imperative UI means that the entire UI in the state of the screen is recreated on every frame, which suits our purposes to demonstrate static Hermes very well. This demo runs 100% compiled native code. JavaScript runs in every frame and recreates the entire state of the screen. It is portable to all platforms, though the screen layout is not optimized for phones. We wrote this demo in C++ and in JS to compare, and they both ran with the same performance. In the attached video, you can see my demo running at the stable screen refresh rate, 120 Hz on my Mac, 60 Hz on an old Motorola phone. It includes some widgets, an n-body simulation of planets, a playable game demo, etc. So it's all running in one application in one C++ instance. It's pretty nuts. Do they have the source code? Yes, they do. So here's the JavaScript. It's a good amount of code. It's not as bad as I expected, honestly. It's only about a little under 1,000 lines. That's what I figured. But it's all just JavaScript code. Calls these static Hermes built-ins to bind the external C stuff. But once you have all of that bound, it tends to look just like traditional JavaScript. We have a class image that has all of these properties, as well as like the static Hermes binding for the pointer, where you can set things. Then we have const physics FPS is 60. All of these values all programmed in here, all hard-coded, a bunch of lets. So these are like globals you can access anywhere now, which is pretty cool that you bind some lets and those become effectively pointers when you call them natively. That's nuts. Like, this is just JavaScript code. I mean, it is typed, and these types do look a lot like TypeScript, even though it's a JS file. So I'm sure this would be very angry if you tried to run this code in any traditional JavaScript runtime. But this level of performance is almost certainly worth it if the tooling can keep up. Yeah, push rect with color. This is a TypeScript function. This is just TypeScript. It isn't at the compiler level, but this behaves, reads, and effectively works just like TS. I guess this is what it's like searching for on the page right now. But yeah, you can call push rect image and just run things directly. I see people asking about the inline part, and I'm not honestly sure. My assumption is that when you define this, it's not actually going to make it a function. It's going to do something else. But yeah, not sure. We have more classes. Much as I hate classes, they do make a lot of sense for these like instance-based things like games. Classes and OOP tends to be much more powerful a pattern in those environments where immutability isn't realistic for a lot of reasons. Yeah, this is just JavaScript code. Like I can read this. I could probably make changes to this. It's a single class that has the nBody runner in it, as well as the constructor, which takes in locations and whatnot, and it creates all of the different parts of the solar system, has a base point for them. Bodies is that, and then we offset them as it runs. Advance goes through all of these, and then it advances them based on their current momentums. And this runs on every frame correctly. They mentioned that there was a C++ version. I just want to look at it so my head hurts more. Here's the C++ equivalent. Let's see the lines of code first. Oh, it's a very similar amount. You have this huge pile of includes at the top. Class, public definitions, static. If you line by line compare this, suddenly it makes a lot more sense why these both exist. So you have this like obnoxious pile of like built-in links, which is the equivalent of includes. But what's more interesting is once we get into the classes or these values here, it is actually funny how similar a lot of this code is. The random function, the image class, which is in a slightly different order, but they do effectively the same thing. We have the public values. It's really interesting how much overlap there is in this code. The define of the image color, not what I wanted to do. I'm not going to use all these fancy symbol tools in GitHub, sorry. And they're still doing the weird bitwise operations for it in both the JavaScript and the C++ versions. This one hanging slash, God, I hate C++ and its weird syntax so much. But it's so cool that like these types of calls and like specific hex codes are able to carry over between the two, and the performance is nearly the same. The reason the performance is the same between these isn't just because the code looks so similar. It's because the code looks so similar and the compiled output of the JavaScript side is effectively the same as the compiled output of the C++ side. As they said here, they both run with the same performance. That is nuts. That is so cool. So I'll be sure to link this tweet in the description. So if you want to go check out these demos and maybe even try and run them yourself, you can, because this is dope. It's so cool to see these types of wins. And right now, there's a lot of code that's being written in C++ and written in these other portable native languages so that we can call fast things from JavaScript. But the JavaScript just being in that native layer is going to enable all sorts of incredible things, from building games with JavaScript code to building better animation libraries to fixing scrolling once and for all. JavaScript's getting more and more native. This is just another huge step in that direction, and I couldn't be more excited. What about you? What are your thoughts on a native JavaScript future? I know it's scary. We're going to have to think more about seg faults and out-of-range selection, but the benefits are very real. And I don't think most of us are ever going to have to write the code that becomes the C++ code. And even if we do, it'll be more and more seamless as time goes on. The Hermes team has been working incredibly hard to make JavaScript as fast as it can be, and I'm super hyped about it. If you're hyped about JavaScript performance stuff, you'll probably love everything I had to say about Bun recently, so I'll pin that video in the corner. And if you've already seen that or you're not interested, YouTube thinks you'll like the one underneath it. Thank you guys as always. Appreciate y'all a ton. Peace, nerds.